at lesson 12.1 today, which is evaluating functions. So first off, what the heck is function notation, and then what does evaluating functions mean? So function notation is just a fancy way to say y equals. All right, so f of x equals, we've seen that a whole bunch before. It means y equals whatever the second side of that equation is. We've also seen g of x equals and h of x equals. And if you look down a little bit on your paper, you'll notice that we have problems set up where f of x equals one function, g of x is a second function, and then h of x is a third function. So having the letter helps us represent which function we're talking about with very little extra writing. So if I'm talking about the function f down here, I would use f of x. If I was talking about the second one, which is negative 5x plus 3, I would say g of x, or g of a number. Okay, so it just draws your eye to the correct function. Okay. Another use for function notation is talking about a very specific thing in the real world, such as area. We can find areas of squares by doing a of and then using s as our variable. So the area of a square function is a of s equals s squared. Okay, the area of a circle might be a of r. So the area of a circle where the variable is r is pi r squared. Okay, so you get different types of functions that have different letters in them, and they mean different things. Today we're going to be focusing on the problems that are just f of x, g of x, and h of x, but you could see these in future courses. Okay, so what does evaluating a function mean? It means plug a number in for x and simplify. So you're going to use PEMDAS, order of operations, in order to simplify that right-hand side of your function once you get that number plugged in. Okay. As you plug the number in, especially if it's a negative number, you probably want to put parentheses around the number just so it doesn't look like you're subtracting. It looks like you're multiplying. Okay. Last thing on here, f of a number means we are using the function f. So it helps you choose which function you're talking about, and plugging in whatever that number is. Okay, so we would be plugging in 2 if this said f of 2. We would plug in negative 5 if it said f of negative 5. So using the function f and plugging in whatever that number is on the inside. Okay, I'll stick with these colors. So the purple is going to represent whatever the number is inside, and then f represents the function that we already have. All right, so example number 1, find f of 5. F is the function 6x minus 1. So let's rewrite that to start with. F of x equals 6x minus 1. When we rewrite, we're going to put f of, and instead of x, we're going to put a 5. Then on the right-hand side, instead of x, we are also going to put parentheses. And inside that parentheses, you're going to put a 5. Okay. Then you work out the right-hand side. At this point, depending on what your teacher says, you can plug this into a calculator and just get it simplified out, or you might have to solve it by hand. PEMDAS says multiply and then subtract, so let's do that. 6 times 5 is 30. Bring down that minus 1, and then 30 minus 1 is 29. Okay, so f of 5 is 29, and you just bring down that left side the whole way. The function f evaluated at x equals 5 is 29. Example 2, g of negative 6. I'm going to use a different color for g. So how about blue for g? So g of x is negative 5x plus 3. We're plugging in negative 6. So everywhere you see an x, you should put a set of parentheses. And then inside those parentheses, put a negative 6. All right, let's work it out. G of negative 6 equals, work out that right side, multiply before you add. So negative 5 times negative 6 is positive 30. And bring down that plus 3. Then when we add together 30 plus 3, we get 33. So g of negative 6 is 33. Of course, you don't have to use different colors. I'm just hoping that that'll help it stand out for you guys a little bit better. All right, next problem, h. So h of x is 3x squared plus 4. Let's plug in negative 7. So like before, everywhere we see an x, you should put a set of parentheses. This is helpful for several reasons. First off, if you're plugging in negatives, it shows that you're not subtracting, you're multiplying. For another thing, especially in this problem, it shows what is supposed to be squared. Okay, so any problems where there's an exponent like a 2 or a 3 or a 4 up here, it says that the negative 7 in this case is the only thing that's getting squared. And then this 3 that's on the left, that coefficient, is going to get multiplied times it later. Okay, so let's do this. H of negative 7 equals 3 times whatever negative 7 squared is. Okay, so negative times negative is positive for that 7, and 7 times 7 is 49. So 3 times 49 plus 4. So h of negative 7 is 3 times 49, which should be 147. Bring down the plus 4, and then add those two numbers together, and you get 151. Okay, so something I want you to notice on these problems is your answer is always just a number. So it's like h of negative 7 equals, and then a number. There's no x's left over. It's just one term, and you're done. Let's take a look at number 4. What's different about number 4 here is we have f of 2 plus g of 3. We have two different letters of functions. So we're going to use 2 when we plug into f, and we're going to use 3 for x when we plug into g. Okay. F of x is 6x minus 1, and g of x is negative 5x plus 3. So let's figure out what is f of 2, and let's figure out what is g of 3. Okay, just like before, let's plug in the numbers. We'll plug in a 2 on the first function. 2. And simplifying that out, on the right-hand side, we get 6 times 2 is 12, and 12 minus 1 is 11. And then our g function, g of 3 equals negative 5 times that set of parentheses plus 3. Parentheses everywhere there would be an x. Okay, simplifying, multiply before we add. So negative 5 times 3 is negative 15. And then negative 15 plus 3 is negative 12. Okay. Now the problem said, what is f of 2 plus g of 3? So we're just going to take these two answers and add them together. 11 plus negative 12, which is negative 1. So you can do other operations with your answers besides just having the answer to begin with. All right, we got 4 more functions down at the bottom. Now that we know how to do it, this should go a little bit faster. Right. Number 5 says find h of negative 5. Okay, h is 4x squared minus 7x. Okay, let's plug in parentheses everywhere there was an x. Ooh, notice there's 2 spots with x's in this function. That means it's going to take a little bit more effort to solve it out, but that is all right. We can totally do that. -5, -5, and -5. And let's do our work. Okay, PEMDAS order of operations says that we should square before anything else. So we are going to square -5. -5 times -5 is positive 25. Okay, so we've got 4 times 25 minus 7 times -5. Okay, 4 times 25 is 100. And then -7 times -5 is positive 35. And then we add those two numbers together and get 135. Okay, and that's our answer. Number 6. This one's a little bit different because instead of just having f of -6, we have a -2 right up next to that f of -6. If a number is right next to something, that means multiply. So this is the same thing as -2 times f of -6. So let's find f of -6, and then after we do that, we'll multiply it times 2. Okay, f of x in this set of problems is x minus 3. Okay, so everywhere we see an x, we'll put a set of parentheses. Okay, x was -6. Okay, so this is going to equal -6 minus 3 is -9. Okay, so that's f of -6, but we're trying to find -2 times f of -6. So let's do that. -2 times, well, f of -6, we found that in the last part of the problem, it was -9. So we'll just multiply those together. -2 times our answer from before is 18. All right, I'm going to show you guys the calculator way to do these problems, because you can do it with a calculator, and sometimes that is a lot faster than doing it by hand. Sometimes it's not, but you will find that when you're taking the ACT and you have 60 minutes to do 60 questions, this could be pretty helpful. So get familiar with it right now. Okay, so first off, what you want to do is go to your y equals. Okay, so that's that top left button, y equals, and you get this screen. Okay, you're going to then type in -2x plus 8. So that was our g of x function, and example 7 uses g of x. It says g of -3. So you type in -2x plus 8. Okay, the next thing you're going to do is hit second table. And of course, it gives you the table for if you plug in this x value, you get this as your answer. So if the number inside is one of these, inside the parentheses, is one of these numbers, you evaluate that function and you get these numbers on the right-hand side. So it saves you from doing all of that work by hand. Okay, so our problem said g of -3. So that means we're plugging -3 into the function. Well, -3 is not showing up, but if we hit the up arrow, we get -3. When we plug -3 into our function g, we get 14 as the answer. Okay, so into y equals, you plug -2x plus 8, and then you hit second graph to get the table, and you scroll to x equals -3. All right, let's do the same thing for h of 6. Now remember that h of -5 kind of took a lot of work, and it's a little bit tricky here where we have the squared and the multiply. So let's plug in to our y equals. We'll go up here. You can hit clear, or you can go down to y2, and you would just be looking at that second column. I'm going to do that just so I can show you. H of x is the function 4x squared minus 7x. Okay, so there it is, 4x squared minus 7x. Notice that was in y2. So when I hit second graph to get to table, these are still the x values that are getting plugged in. The y1 is what g of x would give us. Y2 is what h of x would give us. Okay. We are supposed to plug in 6 to evaluate function h. So we'll find 6 here, and h of 6 is 102. All right, and we are done.